In the last video we discussed about polynomials and rational functions. So now see how to handle some complicated trigonometric identities. We introduced theorem 3, which states that limit x tending to 0 sin x by x is equal to 1 and limit x tending to 0 1 minus cos x by x is equal to 0. These are theorem 3. Now how do we know that these really work? Actually, their proof is quite interesting, so I am going to show it. To prove above theorems, we need sandwich theorem. We will see in this lecture what is it and how it proves the above theorem 3 using geometry. So, sandwich theorem. Basically, sandwich theorem states that if we have functions fx, gx, hx which follow the condition fx less than equal to gx and gx less than equal to hx, and if limit x tending to a fx is equal to some number L and limit x tending to a hx is equal to that same number L, then we can say that for some real number a, if limit x tending to a fx is equal to limit x tending to a hx and it is equal to some constant L, then limit x tending to a gx, the middle function, it too is equal to L. Now as you can see in this figure on the right side, gx lies between hx and fx, and since this function is sandwiched between the above two functions, this gives this theorem its name, sandwich theorem, and you can see they both converge at nearly one point at point A. So to prove above theorem, we will need to prove cos x less than sin x by x less than 1 for range x 0 to pi by 2. Sin is positive in this range. So let's look at geometry, how beautifully we are going to prove this. So we construct a circle we have the center O and two radii OC and OA with a small angle x, and we form this triangle in such a way, and we see that BA is parallel to CD and x is a small angle in radians. We also join AC, and now see how we are going to prove this using just areas. Now area of triangle OAC is less than area of sector OAC. As you can see in the image, sector is greater than that small triangle OAC. Let's call these R, and these are less than area of the biggest triangle OAB. So we are using this condition and simply substituting the formula of half into base into height and area of sector x by 2 pi complete angle 2 pi multiplied pi r square. So this gives us CD less than XR less than AB. So from figure, using sin x and tan x relations for CD and AB, we simply substitute CD and AB into this. Cancelling R from both sides gives sin x less than tan x. Now dividing both sides by sin x, we get this. Now we can simply take the reciprocal of this to get the desired result we are looking for. Taking reciprocal, we get cos x less than sin x by x less than 1. Now can you see something? This first function is x, second is gx, and the last one is hx. Now limit x tending to 0 cos x and hx gives same value. So we can use sandwich theorem, which says gx should also tend towards same limit, and this proves our theorem 3, limit x tending to 0 sin x by x is equal to 1, hence prove. Similarly, you can prove the other one. You can try it yourself. It just uses the identity 1 minus cos x is equal to 2 sin square x by 2. Now let's try some examples. Limit x tending to 0 sin 4x divided by sin 2x. So we simply divide and multiply numerator by 4x and denominator by 2x. These values become 1 and we are left with 4x by 2x, which simply gives us 2. Let's take another example. Also, following above logic, we can also say that limit x tending to 0 tan x by x is equal to 1. You can try it yourself as a little practice. Okay, so let's look at another example. Limit x tending to pi sine pi minus x divided by pi minus x. As we saw earlier, we can take this limits to be y and limits changes y tends to 0 sine y by y, and it simply turn out 1 by pi. Simple, isn't it? Now, some practice questions for you to try. These are some easy questions that you can solve. You can try them. If you are unable to try, you can simply look their solutions using AIs. But please first try them yourself. Give yourself some practice, okay? So these are to revise the topics of today's lecture. Also, let's try some harder problems. You will need to use your creativity and some more maybe formulas more than I have shown in this lecture. So try these out. I have given the answers here so that you don't have to worry about, and you can just verify the solutions you get. Okay, see you in the next video.